Hi, we're back now for part 2, and in this video we're going to show the machining of putting these rounds on. We're going to be putting them on all 4 sides, as well as we'll be taking and putting a nice full radius on this as well. And what I did, because I don't have a turntable, I just keep a lot of hot roll round, just made a simple little jig fixture I can set up. Just got a quarter dowel pin, and what I did is I hard turned this down using the method that demonstrated in one of our earlier videos, hard turning on knee mill. Made this at 239, the same diameter as what these holes are, real good. It's just a nice slip fit, and that acts as my pivot point. I got the clamps, some screw holes and clamps set down, working as stops. I'm using an 1/8 inch end mill, and I'm going to be pivoting on that pin and moving this by hand. Now, if you're going to do this, you want to be really careful, follow a couple simple rules, because it is dangerous if you don't do it right, and I wouldn't even recommend that you do it unless you really have a little bit of experience and feel comfortable with it. One, I always try to use an extremely as small of an end mill as I can. In this case, it's an 1/8 inch. That way, if as you're pivoting on this point, if that would catch and want to spin the part, that end mill, especially being carbide, has a very good chance of breaking before there's any real damage that is done. If you have a 3/4 inch carbide end mill and that spins, it could get ugly real fast. So that'd be the primary thing that you want to do. 2, you want a conventional mill. You don't want a climb mill. You have more control, because when you're conventionally milling, you're pushing into the part and you got a good feel for it. If you're climb milling, it's going to want to wrap that part real quick and kind of self-feed. So you don't want a climb mill when you're doing this. And so you want to take light cuts. Don't take any heavy cuts. You just want to, like I say, approach this very careful. Now, I already got the one radius on the one side set up, and I already cut that. So what we're going to do is we're going to cut the radius on the opposite side, and then what I'll have to do, I'll have to reset my clamps and flip it over and do the other 2 sides. And I already roughly did the math for this, where I need to be with my 1/8 inch end mill. The center line of my spindle is lined up on the center line of the dowel. I'm coming over a 1/4 inch plus half my end mill, 1/8 inch, so 312, plus I want a little clearance, so I've been going like 310. I set this as close as I can into the corner and set this where it stops. It's going in just a little bit. If I want to do the math on the CAD, I can, and maybe in the future when I make a different base I will. But this one here, it's kind of prototyping it out, just seeing the methods work real good, and I'm not real concerned with it. It's fine enough for me. So what we're going to do, we're going to start with this, and I'm going to wind back on my digital, so I'm not taking a big cut. I have everything set with the stops. Oh, got to turn the 3-phase converter on. You can feel that cutting. It cuts real nice. Again, just take light cuts. I'm pushing down to keep pressure on the plate. It is cutting easy. I've taken up to, when we're starting, up to about a 30,000th cut, which is a little heavy, but it worked good. Now I'm getting into where it's cutting more. I'll probably go about 15, 20 thousandths a pass. But you can feel the cut. You can tell about what you're going to get away with as you're cutting. And again, if you're not experienced in this, I wouldn't recommend doing it. You want to keep the chips cleared out, especially on your last pass, so that they hit to the stop just right. And now you can see we have the radius done on this side. I'm going to step over and use the Scotch-Brite deburring wheel on there and just take that edge off a little bit. And then I'll show you how we set the stops and get that all figured out, and then we'll do the two opposing. Basically, I'll take one of these clamps, and if you watch some of our previous videos, you might recognize some of this hardware. For someone like me, you can never have enough of this stuff. Comes in handy for so many things. What I'm doing is I'm setting a back rail. There's different ways that you can do this. This is just something fast and easy. I'm going to use this 30, 60, 90 degree template. You know, clean. I put the back rail on so I can set that like so. And then I can set this so that it's at 90 degrees. It doesn't have to be perfect. We're not doing any high precision. We're just making clearance radiuses and everything. So it's closer than eyeballing it. So that has stopped me pretty much at 90 degrees to the dowel pin that way. When I come over on this side, let's see. What I'm going to do is move my digital about 350 or so. I'm going to have to go further than that. Oops, got to leave it in the X this way, or in the Y. Leave that at 0. I could always slip a dowel pin in here and make it work a little bit, but I'll just try to work it off the flutes of the mill just to roughly get it close. And looks like we're going to run into a minor little problem here. Let me see if I got a different clamp that's a little bit longer. I use something like this, all I need to do is make a stop point. Yeah, that's not going to work. Let's see. If I had a few more tap toes in the plate, and then I would have more positioning I can do with it. So what I'm going to do here is I'm just going to go at an angle, catch it in the corner. I got my reach that way. And then I'll have to come to this side and take a look at it. And I think we got it. Okay, so in order to conventional mill, I have to go this way. If I go this way, I'll be climb milling, and I don't want to do that because it would take a chance on getting away from me. Got a little greedy there and taking a little bit too big of a bite being that close, but still working out fine. So now that's the third side. What's going to happen is later on we'll be cutting this a slot in the center section, or in the center part will be all removed. I went deep enough with the end mill. I went like 150 deep, and if I remember right, these are about 100 thousandths roughly is what these tabs will be. So by the time we remove this part into there, you'll just have the two round parts sticking up. We have one more side to go, and then we have the other pin. Once your end mill is touching the entire part, never take your hands off it and let it rattle around. You can have some unpleasant results doing that. as well as the potential of getting hurt. So again, if you feel comfortable with this, you know the difference between climb milling, conventional milling, and you're careful with this, you could do this kind of work. There is a little bit of a danger factor, but if you take it easy, it's really not that bad. There's other things that you can do on a mill that will be worse than this and more dangerous. But now you can see we have this radius on all four sides. So it was something that you popped them on there, they went real good and fast. Went a little deeper in this area, which is fine, because again, it's just strength. If I was going to make these to sell rather than personal use, I would CAD that out so I'd know exactly where to stop with my angles and numbers and everything. But this is going to work fine. It's kind of a prototype anyhow. What we're going to do now is we're going to set up on this one, and we got to make that full radius on here. I already cut this area out right here on both sides, and this one I'm going to switch to a different end mill. This has got a 1/4 inch flute length. I'm going to switch to one that's got a 1/2 inch flute length now, because I got more flute length. I want to be probably a little less aggressive on taking my stock off. One, I don't think it's going to be a matter that it's going to want to grab as well. I think what's going to happen, I got to be more careful, because with the carbide end mill, it takes very little pressure to break, and so I don't want to break that on there. So I got to change end mills out. And we'll have to get this set up. And it should be good that way. I keep wanting to change the Y, but I got to leave that on 0. Because I'm taking a bigger cut with more surface on the end mill, I'm going to take only about 10 thousandths at a time. Just using some common sense. I'm more concerned about it breaking the end mill than I am as far as it getting away from me, but I prefer that neither one of them happen. Yep, right there. Yeah, you can definitely feel the difference cutting with a deeper cut and a longer end mill. One thing that's also important on this is that the pivot hole that you have and the pivot pin, you want them to be as good of a fit as you can. If it's sloppy, it's going to give you a bad finish, but it's going to be really hard to control as well. So you want to have the pin and the pivot hole probably within just a few tenths of each other if possible. And this should be the last pass. So now you can see we got that radius established on there as well. And so we'll probably stop right here this week. And what we'll do between now and next week, I will just do some of the other machining, milling the slots in these parts right here, milling the material off of here. I left the material big here, all this material on, so it wasn't such a thin piece there. I wanted to have more control as I'm pivoting that, and if I would have removed this all the way off to the proper thickness that it will end up with, it would have been a little bit hairy. I also got to remove all this material in here, and I left it on there for the same reason, because I wanted as much material a surface as I could get on the pivoting. This method, I've used it for a lot of stuff. If you look at our introduction video, you'll see that somewhere in that video we built a 20-inch disc sander using the same method. If you haven't seen it, you might want to watch it. We were taking with a special T-nut slot that I made that had a dowel pin in, and we're pivoting using this method, a 20-inch aluminum plate. And so we made all the parts for that disc sander that are round. The guarding was actually bigger than 20 inches. We built that right here on the mill. So there's a lot of neat things you can do with the mill if you know how to use it proper. There is a danger in everything that you do. You want to eliminate as much of that as possible. And like I say, in this case, you just use the small end mills, take light cuts, make sure you keep a good hold, don't let things go. You conventional mill, you're pushing into it rather than climb milling. If you climb mill, it will have a tendency to grab and rip away from you, and you could get hurt, but most things that will happen is it'll rip away, it'll come around here and hit, the end mill will break. The carbide's very brittle, so if you use a smaller diameter, you'll be good. Never use big end mills for this type of work. I think on that This sander, if I remember right, I started out with a 3/8 end mill and was going through. Now, I had a lot more leverage as I spin in this plate on there, but even then I could feel it was a little bit hairy, and aluminum as well. Cutting aluminum, I was using regular carbide end mills rather than some that was specific to it. But as I got about halfway, 3/4 down in that plate, I actually switched to a 5/16 end mill so that it would only be touching on one side. So just use some common sense, and you can do some neat things like that without having to buy expensive toys like turntables and all that stuff. So this will be it for this week. Next week, I'll finish up the machining, and what we'll do, probably the next video in this series is going over the heat treat. Then we'll have the grind, and then we'll have the jig, well, kind of the rough grind, the jig grind, and then we'll do the finish grind. What we'll do, I don't want to have it finished ground, because when I jig grind these holes, I already know our jig grinder is going to grind a few tenths off. So what I'm going to do is I'm going to establish the 4 inches between the holes, knowing it's going to be off a little bit. And then what I'll do is I'll grind everything to the holes in there, and it should work out fine. And in the future, I'll probably make different versions. I got this, it's only going to be 200 thousandths thick. It's probably going to be a little light, but what I wanted to do was get this low profile. And I didn't mention it in the first video, but when both parts are together, it will measure about 650 thousandths in the height compared to this one, which is 1 inch and 50 thousandths. So it will be quite a bit smaller. It'll give us more room. I'll be able to slide it around in the vise more. In the future, if I make one with an extension that comes out this side, maybe might make it another 50 thousandths thicker, maybe a little longer. I'll be able to move this across this gap in the bed, and then that way it would just help me when I'm positioning some of the work that I may be doing in the future. So anyways, that'll be it. Well, thanks for watching. We'll see you next time.